So in theory, you should be able to do problem 79 now. Make a table, fill in the y values underneath the in the right-hand column, sketch a graph, complete the table, sketch a graph, find the domain, and find the range. I'm going to do problem 82 next, which is the graph of a cubed root, and I don't know how readable this is. And it asks me to graph the cube root of x plus 3, and it gives me a very detailed table. This is ridiculous to have decimals in my x column. When you do problem 81, don't worry about doing the decimaled x columns. I'm not sure how well this is or isn't showing up. I've got some glare issues going on right now. But in problem 82, I'm asked to complete a table, and the x column has more numbers than I need. But I'm going to do -5, -4, -3, -2, -1, 0, and 1. And the y column, I'm going to get using my calculator. I'm not going to run into the same error issues that I did for the square root graph, because the cube root of a negative number is a negative number. So let me start here and get my first y by doing h of -5. That's going to be the cube root of -5 plus 3. And I don't care to do that by hand. I need to round to 2 decimals again. So shift cube root -5 plus 3 and round to 2 decimals. Ugh. I get -1.259, and that 9 is going to round that up to a 6. And so for in my y column, I'm going to write -1.26. And same deal here. I'm going to complete the table. While I'm completing the table, I'm going to sketch a graph. After I get the graph done, I'm going to find the domain from the graph and the range from the graph. The first point I get to plot is the point -5, -1.26. And again, 2 decimals is probably kind of silly in terms of believing I could plot that accurate, but I'm going to, the best I can, plot that point. It's not quite written as a point, but the table kind of implies the point to me. So first point, x equal to -5, so I go over to -5 on the x-axis. H of x, or y, equal to -1.26. So -1.26 maybe is down about there. I'm not even going to write that point in. I'm just going to dot it the best I can. And now I'm going to do h of -4, which is the square root of -4 plus 3. Cube root of -4 plus 3. And that's going to give me -1. So -4, -1 is about there. And then h of -3 is the cube root of -3 plus 3. That's going to be 0. I wonder if I could just go back. I think I could just go back here and change that to -3. And that gives me 0. So I'm going to plot the point -3, comma 0. -3 on the x-axis, and 0 on the y-axis. 0 for y is on the x-axis. That's the point -3, 0. And then h of -2 is going to be the cube root of -2 plus 3. That's just going to be 1, I think. Cube root of -2 plus 3, that's just 1. So that's going to be the point -2, positive 1. And now h of 0 is going to be the cube root of 0 plus 3. Did I do that? I forgot to do h of -1. Oh well. I'm going to do h of -1, which is this cube root of -1 plus 3. And the cube root of -1 plus 3, rounded to 2 decimals, is positive 1.26. I'm not getting any errors here because the cube root of a negative number is a negative number. And then h of 0 the cube root of 0 plus 3. Rounded to 2 decimals is 1.44. So 0 on the x-axis, up 1.44, which is a little bit under 1.5. And then finally, h of 1 is the cube root of 1 plus 3. Shift cube root 1 plus 3. And I'm going to round that to 1.59, which is like 1.6. So I've completed my table. Starting to graph the points, and cube root graphs, unlike square root graphs, they extend forever. They don't have a hard ending or starting point. Cube root graphs are kind of, I don't know, S-shaped. They go off forever to the right because my table, I could make bigger values of x, and every time I'd make a bigger value of x, I'd actually get a bigger value of y. But unlike the square root graphs where I start getting errors, the cube root graphs are going to go off to the left forever. I could make my table have more negatives in it, and I'm not going to get the errors. So this is not maybe the most stellar graph ever, but it's a fine graph for this cube root. My graphing calculator, one thing it does do is it draws graphs very well. So to give you a better perspective of how this graph can look, I'll just break out this clunky graph and just show you what the graph would look like. So the cube root of x plus 3, this is more or less how the graph should look, and my graph will look something like this, but maybe not as much like this as my calculators, but it's not horrible. So there's my graph. I completed the table. I sketched a graph. Square root graphs always have a hard starting point because the square roots of negative numbers are imaginary numbers, but cube root graphs go forever from the left edge to the right edge of the x-axis always. So done with sketching a graph. Now I'm going to find the domain, and unlike the square root graph where I can find the left edge of the graph, there is no left edge. If I try to say there's a left edge, there isn't. There's no left edge. When I go to find the domain, I like to find the left edge of the graph and find the x coordinate. But there is no left edge because no matter where I say the left edge is, the graph goes down and to the left forever. So this graph, it doesn't really have a left edge. It winds up working its way all the way to the far left edge of the x-axis, and the infinity at the far left edge of the x-axis is negative infinity. So for this graph, the domain is going to start at negative infinity because there isn't a left edge. Similarly, when I try to do the right part of the domain, there's no right edge to the graph because the graph goes forever to the right. And when the graph doesn't have a right edge, we say that the end of the domain is at positive infinity because the graph goes all the way to the right edge of the x-axis, and infinities always get round brackets. For our class, all cube roots that we graph will have a domain of negative to positive infinity, whereas our square roots have a domain of some value of x comma infinity. For this next part that I need to do is find the range. To find the range, I need to know the bottom of the graph and the top of the graph. Similarly, this graph, there is no bottom. There's no lowest value because if I said this was the bottom of the graph, well, this graph extends forever down and to the left. It goes forever and ever and ever, and there's no place I can say this is the bottom of the graph. When the graph doesn't have a bottom, then the bottom of the y-axis is the start of the range, and the y-axis has a start of negative infinity. So when the graph doesn't have a bottom, there isn't a lowest point, then the graph extends down to the bottom of the y-axis, and the y-coordinate of the bottom of the y-axis is negative infinity. This graph also, it has no top. And to find the range, I need to know the y-coordinate of the bottom of the graph and the y-coordinate of the top of the graph. But there is no top, because no matter what if I said something is a top, I can continue the graph up and to the right forever, and there's always going to be a higher point. When there is no top of a graph, the top of the y-axis is the end of the range, and the top of the y-axis always has a y-coordinate of infinity. So the end of my range is going to be infinity. And for our purposes, all cube roots that we graph will have a range of negative to positive infinity. They'll have a domain of negative to positive infinity. And for our purposes, for all square roots that we graph, the domain is going to be square bracket some value of x comma infinity, and square bracket some comma y comma infinity round bracket for the range. All right, there is a way to get tables way faster on this calculator. I will record a special video to show you how to get the tables more efficiently on this calculator. If you own a big graphing calculator, boy, they do tables really well. I can show you how to get the table on your calculator so you don't have to do each line on the table individually. All right. The next problems that we're going to be asked to do are 83 and 84. Let me do 83, both of them, which is a homework problem, just to knock out one of your homework problem. And in 83, there's a part A and a part B. And 83 gives me in part A a square root. And it asks me to make a table and sketch a graph. So I need a table. But it doesn't give me the starting table. I'm going to make a table. I'm going to sketch a graph, and then I'm going to find the domain in the range. The only thing that's different in problem 83 from the first two problems that I did is it doesn't have a starting table. Always, when I'm doing a graph, to get my table, I'm going to worry about the radicand. So for my x values in my table, this is what I generally do. If I'm not given a table, I solve the radicand, which is what's under the radical, equal to 0. In this case, in problem 83a, the radicand is x minus 4. I'm going to solve x minus 4 equal to 0 by adding 4 to both sides. And when I go to do my table, that's the number I'm going to slam in the middle of my x column. So if I'm not given a values of x's for my x column, I take the radicand, set it equal to 0, and solve for x. I put that number in the middle of my x column, and then I usually put 2 more numbers bigger and 2 more numbers smaller than the number that my algebra gave me. So my table in 83a is going to start at 2 and end at 6 because 4 is going to be the number in the middle. So now for each x, I'm going to get a y, and then I'm going to sketch a graph. After I sketch the graph, I'm going to find the domain in the range. I'll make my x-axis go out to 6. And my y-axis, maybe I'll call f of x, but I could call it y. I'm not sure how high to make it, but these things don't get very high, at least very fast. So now for each x, I need to get a y. So the first one I'm going to do is f of 2, which is going to be the square root of 2 minus 4. I'm going to get an error for that because that's going to wind up making me find the square root of a negative number. So if I did the square root of 2 minus 4, I get an error. I'm just going to write error here. This is not going to show up on my graph. Next, I'm going to do f of 3, which is going to be the square root of 3 minus 4. That ultimately is going to be the square root of negative 1. And that's also going to be an error because square roots of negatives are imaginary numbers. They won't show up on the graph of a square root that we're doing. For f of 4, it's the square root of 4 minus 4. I can do that without my calculator, but I'll do it with my calculator just fine here. The square root of 4 minus 4 is going to be 0. That's going to be the first point I get to plot. I'm going to get the rest of the y's just to speed this up. And then graph them all at once. So square root of 5 minus 4 is going to be just 1. And then f of 6, the function, the f doesn't make a difference. It's just the number in the parentheses that does. And then the square root of 6 minus 4, SD it so I can get a decimal. So it's 1.41. So I've completed my table that I had to construct myself. Now I'm going to graph those points. The first 2 points don't start anywhere. They don't get graphed. And then I'm going to plot the point 4, 0. That's going to be the first point. That's the point I need for both the domain and the range. And then 5, 1 and 6, 1.4, the best I can. All square root graphs kind of have the same look. They're half of a u on its side, essentially. All square root graphs that we do will have a hard starting point, but they'll go forever to the right. So I made my table, sketched a graph. I labeled the first point that's after an error because it's going to be the start of my graph, and it's going to help me get the domain and the range. For our purposes, when we're doing the graph of a square root, the domain is going to be square bracket, comma, round bracket. The x from the starting point of the graph is going to be the start of my domain. It's a point on the graph, so it gets square bracketed. And the graphs always make their way to the far right edge of the x-axis, and the x-coordinate, the far right edge of the x-axis, is infinity. And for all our square root graphs, it's going to be square bracket, comma, round bracket. And the point that at the bottom of the graph, its y-coordinate is 0. And this graph will eventually make its way up to the top. There is no top of this graph. The graph goes to the top of the y-axis, and it's going to be infinity. For all of the graphs that we do, all our domain graphs, our square roots, the domain is some x comma infinity, the range is some y comma infinity, and it's always going to be the starting point here. And then for the cube root graphs, it's double infinities for the domain and the range. So now I want to do 83 part B. I'll do it on a separate sheet of paper. And I'm going to have to make the video hiccup again because I'm getting to a break point here. So for part B of 83, which is actually one of your homework problems, I'm given f of x equals the cube root of x minus 4. I need to make a table. I need to sketch a graph. I need to find the domain, and I need to find the range. For our purposes, every cube root graph we're going to do, the domain and the range are going to be double infinities because the graphs aren't going to have a left edge, they're not going to have a right edge, they're not going to have a bottom, they're not going to have a top. All the cube root graphs we are going to do are going to look kind of the same. Similarly, all the square root graphs we do are going to look kind of the same. So without even having a table, just the fact that this is a cube root, I know that both the domain and the range are going to be double infinities. Also, when I go to make my table, if I'm not given a starting table, to get my table started, I look at the radicand, what's under the radical, I set it equal to 0, and I do the algebra to solve for x. This is going to be the number in the middle of my x column. So in the middle of my x column, I'm going to put the number 4. And then I'm going to do smaller than 4 by a couple, bigger than 4 by a couple. That's going to be the x's for my table. I'm going to get my y's, which I could also call f of x, using my calculator. I'm going to do f of 2, which would be the cube root of 2 minus 4. Then f of 3, which is going to be the cube root of 3 minus 4. And then f of 4, which is going to be the cube root of 4 minus 4. F of 5 would be the cube root of 5 minus 4. And f of 6, the cube root of 6 minus 4. I'm going to do all of these really quickly on my calculator and round to 2 decimals. So first one, shift cube root of 2 minus 4. Round it to 2 decimals, that's negative 1.26. And then just back up here, change this to 3. The cube root of 3 minus 4 is negative 1. Back up here, change that to 4. The cube root of 4 minus 4 is 0. Back up here, the cube root of 5 minus 4 is 1. Back up here, the cube root of 6 minus 4 is 1.26. I'm going to plot all these points the best I can and call it done. So on my x-axis, I need to get out to 6. And on my y-axis, I don't need to get much higher than 2 or much lower than negative 2. If I had a bigger table, my y's would get really big and my x's would as well. So now I'm plotting these points. First point, positive 2, negative 1.26, the best I can. Negative, positive 3, negative 1, positive 4, 0, positive 5, 1, positive 6, 1.26. All the cube root graphs look kind of the same. They're these S kind of shapes that look like this. And there's no right edge, there's no left edge, that's why the domain is negative to positive infinity. There's no bottom and there's no top, that's why the range is negative to positive infinity. All cube roots, the domain and the ranges are double infinity, negative comma positive infinity. All square roots are going to have numbers in the beginnings with square brackets. All right, I'm going to hiccup the video and we'll do one more problem and then we'll call this done.